How many of you have heard of duck typing before? Good. This talk was originally given at a Python conference. I thought about attempting to adapt it for this conference by just changing half of the examples to Ruby, but I figured I would probably do a bad job because I would just be making everything up. And generally, I much prefer that a Clojure person will just show me something in Clojure that they know really well than that they try to come up with Python for the same thing. But the lessons here are intended to be useful for any dynamic language, whether it's functional, procedural, or object-oriented. But I first noticed the phenomena of which I will speak when I started to pay attention to how people in the Python community use the adjective Pythonic, by which they mean not the syntax of the language, because you have to write the syntax correctly for your program to run, but programmers were beginning to follow many additional rules that had nothing to do with the syntax. You can break the rules and write unPythonic code and it will run, but it won't look like Python is supposed to look. And I became very interested in all of these informal rules that good Python programmers were beginning to follow. A lot of the early rules about how we indent code, about how we format it, were put into a standard called PEP 8. For example, it has a rule: limit all lines to a maximum of 79 characters. Because whatever width your screen is, you don't want lines to wrap, and this is a traditional limit that they liked using because many people on wide displays can fit both documentation and their program next to each other if the traditional ANSI terminal width is adhered to. And it reminded me of a rule from a very different discipline than programming. Has anyone here ever done any graphic design? And have any of you ever heard of the elements of typographic style? It is a famous work in the field of graphic design, and it has a similar rule. Anything from 45 to 75 characters is widely regarded as a satisfactory length of line for a single column page. The 66-character line, counting both letters and spaces, is widely regarded as the ideal. And as I read PEP 8, this early piece of advice about how to format Python, I realized I was reading a document about graphic design. I realized that whenever we sit down and begin writing code, because we make decisions about white space and width and formatting, whether we are good at it or bad at it, we are all acting as graphic designers. If you are writing a page of code, you might be ignoring the graphic design and being a bad graphic designer, but you are being a graphic designer of some sort. And I noticed that the community was beginning to have strong opinions about it. So PEP 8 could be thought of as our community's elements of Pythonic style. But I think it gives bad advice. In many cases, I think that it creates fairly ugly code if my function is a little too long for the slide. PEP 8 would have me fit as much as I can on one line and then wrap down to a second line, lining the third argument up with the first one, creating all of this ugly white space off to the left. And if you have a page of text like this, there are gaps everywhere because of the way PEP 8 advises you to wrap the code. I much prefer, if my line is too long, I just go ahead and break it to the second line and will use a 4-space indent. But very often, I find that if I am reading the code later, it is easiest for my eye to scan if I just give up trying to use the whole line and instead stack the 3 arguments vertically and symmetrically, because then my eye can very quickly see how many arguments there are without having to search through the middle of a line for commas. Why, you might ask, do I have the extra comma at the end of message when there does not need to be a comma because there is no 4th argument to separate it from? And that is because the symmetry of having a comma even on the last argument is very friendly to version control. It always annoys me if adding a 4th argument makes me change both the 3rd and 4th lines. The extra trailing comma, if it was already there, means that I get to add another line for free without having to change argument 3. So, when I realized that I did not like Pep 8's advice on how to format, I protested. And where do we protest? Twitter. And I tweeted, I said in Python, when a function name is long and has too many arguments, I tend to hit carriage return right after the opening parenthesis, instead of waiting until I'm several arguments deep into the function. And immediately, an expert Python programmer, he maintains pip that you install things with in Python. The pip maintainer said, yes, the next step is each argument on their own line and never any indent larger than 4. So Pep 8 said one thing. I had found that something else was more beautiful, and without ever having coordinated with each other, another Python programmer had discovered the same thing, as though Python were teaching Carl and I the same lessons independently. And it very much impressed me that programming languages seem to have a logic built into them that you don't know at first, but that is slowly pushing different people in the community in the same direction without them ever communicating with each other. So Carl's tweet has gotten me thinking about how Python has been teaching different people the same things. And my first talk on this subject, you can find it on YouTube, was at PyCon Canada, about beauty in code and the extra rules that we create to make code not just syntactically correct, but beautiful. I will share with you my most popular slide. Many people tweeted and talked to me later to say that this helped them. So here is a function. I am able to fit 2 arguments on the line with a function, but the 3rd argument is too big, so I have to get the function call and make it 2 lines. Well, that creates ugly gaps in the white space, and if I am going to have to go to 2 lines, if I have to have 2 lines, why not get something for that by having 2 separate statements by giving this value a name? I still am going to have 2 lines of code, but now I have documentation. Notice in the first example, there's no name for that big string I'm making, no hint to help me when I read the code later to tell me what that string is for. If I am going to have to go to 2 lines, I often prefer to give one of the values, often the biggest one, a name, so that if I'm going to have 2 lines, I want some free documentation in my code along with it. I adapted this idea from the extreme programming people. Do you remember them like 10 years ago, that a comment is a bug, and they developed all of these techniques? So they would say that this is bad code, the first example, and they would rewrite it to the exact equivalent, but that gets the information hidden in the comment and pulls it into the code, because they say comments are going to get old. People will ignore them, they will fall out of date, they will just confuse you. But if you pull that same knowledge into the code, they had the belief that it would be maintained. And so I adapted this idea to what I do every time a line is too long by giving things names, creating abbreviations for them. I have as many lines of code as I would anyway, but I find it much easier to read. The ideas are each smaller, and I get labels and names for things. So you can see my Canada talk for more thoughts about how coding involves graphic design as we lay out the page. This maneuver got me thinking, however, and this is now the subject of this talk, about naming in Python. T.S. Eliot, in a poem, famously said, "The naming of cats is a difficult matter," speaking of the English and how they name their cats. And I am going to suggest that the naming of ducks is a difficult matter when you are in a language with no types. The name is your only hint, the only shred of information you possess about what kind of value a given name refers to. Python does no type checks. Code relies on duck typing. Here is a sample function that I pulled out of some code, and I replaced all of the names that could be replaced with symbols. And reading this, you cannot tell what on earth this function was supposed to do. In fact, you might guess that the argument named _2 is a dictionary because Python dictionaries, hashes, do have a .get method, but you would be wrong. Here it is with the names filled in. It turns out this uses the popular requests library to get a URL, get the response object, and pull out the text. But you cannot tell that unless the names are well chosen and communicate to you what the intention of this code is. Names are how the Python programmer signals intent. Names are our lifeline. Without types there, they are all we've got. So, if the internal logic of the Python language has been teaching us about graphic design, what might it have been teaching us about names? I watched for several months and have only made the beginning of a study of all of the conventions around naming. But here are 4 that I will quickly go through, 4 initial discoveries that I have made about the practice of naming in this particular language. First, it is very important to have well-factored nouns. Let us imagine that I am writing a program that is supposed to do this. I am supposed to say download.py and tell it what page to download. So I begin to write the top level, and I say, okay, here my main function parses the arguments and then calls a helper function that I'm about to write, download page. And I give it that argument called page so that it knows what to download. All right, so now it is time to write download page. And I say download page, and it's going to receive the page that it's supposed to download. It's going to talk to the requests library, which can do HTTP. And I'm going to say, go get the page. And I'm going to store that in a variable named page. Oh, but I've already used the name page. And it is at that moment that I realize that this thing I've been calling page isn't a page, it's the URL of the page. Okay, I can fix that. I will call the parameter to download page URL. So now I don't have the problem. I say requests, get this URL, the page comes back, and now I can call another function to process the page. All right, I'm going to write process page, and it is going to ask that object, what is your .text? What is the actual string of HTML? And I'm going to call that, oh, well, I guess the page is actually the HTML. This isn't the page, this is the response object that has all of the metadata. Okay, I can fix that. I will call the parameter response, and now I can use the name page for the actual HTML. Now, this is a very simple example, but does anyone detect a familiar pattern that you might have experienced before? What have I done? I have now finished a small program that is in desperate need of refactoring because as you go down, I am getting a value called page and passing it as a parameter called URL. I'm getting an argument called page and passing it into a parameter called response. When I come to people's code that I am unfamiliar with, I cannot guess which values are supposed to go to which parameters because the names at each level of the code are completely different. Very often, this is a general lesson. My biggest mistake as a programmer is thinking I am done the moment a program first works. It is a disaster to stop as soon as your program runs, because the moment your program works is really the moment that it barely works. And generally, I find that if I have that I need to split my time half and half between getting something working and then refactoring it and cleaning it up. If it takes me 30 minutes to get a function running, I should then spend 30 more minutes experimenting, refactoring, cleaning it up, because the moment it first works, it is in a barely working condition and probably needs at least as much work on it to make it code that is not only working code, but good code. And so, how could this be refactored? Each discovery that you make about a name, as you get down to a lower level or a higher level, when you write further code and you discover that a name was badly chosen, it was not specific, you should stop and go change the name in all of the rest of the code, because learning that a name was imprecise is knowledge. And you should go ahead and make that knowledge available everywhere. The knowledge that that was really a URL, push that knowledge up into all of the rest of your code, because generally, as we program, we are always under a severe deficit of knowledge about why the code is behaving the way it is. And all the symmetry and all the precision you can create helps make code carry more meaning with every single line. Many people that are fans of statically typed languages say that Python can never work because it lacks type checking, which is kind of true in the first example I gave. There's no rhyme or reason to how parameter names were matched with arguments. But if you refactor your names, if you go back and clean them up and make the names agree between levels of your program, you get a kind of simple type checking for free, in that you will visually see a similarity in the names of the arguments and the names of the parameters that they are being delivered to. So the first thing I noticed is the importance of well-factored nouns. My advice is that you should exuberantly refactor by pushing name changes back into all your previous code. As I have developed this habit, I found my programs much easier to read a month later. The second thing that helps me understand my code are relentless verbs. In general, for stuff that does something, functions and methods, I like to use a verb. We have a saying in Python, explicit is better than implicit, and I like to make it very clear what a routine is doing. Sometimes I am tempted to be very brief and just have a function called database that I can call. A problem, of course, first is that I would like to use that name for the variable that I assign it to, but it's also not clear exactly what it does. Does it open an existing database? Does it create a new database? And by making sure that the function name includes a specific verb, I find I'm less confused about its semantics when I read the code later. An exception is a method. I actually don't have a problem with a method lacking a verb because it is fairly clear to see that it means compute or return some value pertaining to the object to which it is attached. I find that the fact that with a method I have two pieces of information, the name of the object and the name of the method, I can get away without being too verbose. It's more in the case of a standalone function that I need to be careful to include a verb so that I have some semantic help in knowing what it is going to accomplish. This is very, in a language that is object-oriented, where each object is its own namespace and can have its own .md5 method that doesn't conflict with any other MD5 methods or functions or names in the language. It's often very, very useful to be brief, to not add a bunch of extra words to the method name to try to make it unique. It's already unique because your object-oriented language will look up the MD5 that particularly applies to this object. We love namespaces in Python. We love the ability to not have to qualify names with extra words because they are all in their own module or class or namespace. If you type import this in Python, the Zen of Python will print out. And the last and final mantra of the Zen of Python is namespaces are one honking great idea. Let's do more of those. And the existence of namespaces means that we can make names very brief. One case in which I do not use a verb is in OO languages, thanks to an earlier tradition, it's always understood that the word new is almost a verb, meaning create a new thing. So this is an example where I throw the verb out and just have the adjective noun, new object. Another case where I do not use verbs in my functions is when I'm doing math. You'll note that your algebra professor didn't write things like compute sine and compute cosine up on the chalkboard. Instead, mathematicians simply use a brief noun, always, to name a function by the kind of thing it will return. And so very often when I am writing small, short, pithy functions that do some kind of computation, I don't really put a verb in front of every one of them, because when you move into something that is less like object orientation and more like math, I find that the idea that, that compute or create, that idea sort of comes built in to the idea of a function by default. But except for those exceptions, I generally find that function names should include a verb instead of simply naming what they build or generate if it is not one of those special cases. All right, my third principle is the sin of synecdoche, which is when you use a part or a whole to name a part in Greek rhetoric. In Lewis Carroll's book, Through the Looking Glass, Alice in Wonderland, how many of you have heard of Alice in Wonderland? It is a very silly English children's book, and in the sequel to it, Through the Looking Glass, written maybe in the 1850s, Alice meets a knight who offers to sing, and he says, the name of the song is called Haddock's Eyes. Oh, that's the name of the song, is it? Said Alice, trying to feel interested. No, you don't understand, the knight said, looking a little vexed. That's what the name is called. The name really is the aged man. Then I ought to have said, that's what the song is called, Alice corrected herself. No, you oughtn't. That's another thing. The song is called Ways and Means, but that's only what it's called, you know? Well, what is the song then, said Alice, who was by this time completely bewildered. I was coming to that, the knight said. The song really is a sitting on a gate, and the tune is my own invention. It turns out that that was a lie. The tune was well known, and Alice recognized where he had stolen it from, but the knight's attitude toward naming should be very familiar to you who are programmers. Again, the knight made the distinction between what the name of the song was called, what the name of the song really is, what the song is called, and what the song is, which is exactly the distinction that we have in programming between calling the name URL, and then the name of the resource is actually that string. And then I'm calling in my program the song, but the song actually is that string. In programming, whenever you have a resource with an address, like a path or a URL, and you have to choose variable names for each of those, you are in exactly the situation described by Lewis Carroll. How is he able to come up with a modern programming problem in the 1800s? Because he was a mathematician. His real name was Charles Lutwidge Dodgson, and when he was not writing children's books, he was writing books about the discriminant as they developed the calculus. His next book after Alice in Wonderland was a treatise on the discriminant, and his fans were very disappointed. So, the sin of synecdoche occurs when we confuse a name with what it names. If we use song for something that isn't the song, but is merely one of its attributes. Here, this isn't a document. It's the path to a document. And I find that my code suddenly becomes much clearer and has less ambiguity if I make sure I always name the part. Is it a URL? Is it some text? Is it a path? Naming the part in my code is mandatory. Naming the whole is optional because that might be supplied by the context. Maybe in a very complicated routine, I would speak of the song URL and the song text. But if the entire function or the entire module is about songs, maybe I will leave song off. Sometimes I will name the whole thing, sometimes not, but I always try to be as specific as possible about what part of a larger idea I'm talking about. PEP 8 does get this correct. It says, as an example of what you do not do in Python, the old X11 library in C uses a leading X for all of its public functions. In Python, this style is generally deemed unnecessary because the surrounding module or class namespace can be responsible for naming the whole, while something called MediaLib would probably need to call this function fetch songs because songs are only one kind of media. If I'm in songlib.py, I can just name it fetch. Obviously, that's going to be used for fetching songs. But whether you name the whole thing, songs or not, please always name the parameter after the specific piece of the song, the specific fact about the song that you need. Don't just say song, say URL or text or response object. Interestingly enough, the built-in logging module in Python both gets this right. For instance, it has a class called filter because, well, what other kind of filter would you expect to find in a logging module? And it gets it wrong. You have a logging.log record, as though there would be 10 other kinds of record defined by the logging module. So that's an inconsistency where the author didn't remember that this would be qualified by logging and a dot in front of its name. Short unqualified names are wonderful because they leave the caller, the person who uses your code later, in charge of whether to qualify them. In Python, if I think I can just use the name fetch unambiguously, I can just pull that name out of the module into my local namespace. But if I think that that might confuse me later, I can instead import the entire module by name, and that way I get this little bit of extra documentation every time I call fetch, reminding me what kind of thing this fetch function goes out to retrieve. So, avoid the sin of Synecdoche by always being explicit about wholes and parts, but feel free to split a whole and part between the namespace that tells you all of these functions operate on songs and the specific names that can just be verbs. So, good Python programming is often about doing what you ought to do rather than just what you can. Writing good Python is often just a very long exercise in propriety, being polite and following sensible rules, even though the language doesn't care what you name things. Finally, I do not have a final judgment on pluralization. The fact that should a container get a plural name or a singular name, then with some extra help to tell me that it is a container. There's someone who released a very popular new Python module called requests, and I'm like, why didn't he name it requestslib or weblib or something? Because I very often use a plural for a list or container, which means that it works great until I'm using his library and have more than one request, because he has already taken the name requests to be the name of his library. That is not the general problem of pluralization. The problem I'm thinking of has three prongs. Python has many containers. If I use a name like connections, how am I to remember what kind of container it is? Plurals in English aren't always unique. There are several words whose plural is the same word without an S on the end. And often we use the plural to name a counter. Connections can just be the number of connections. And then, of course, that's a whole other topic. How do you name? There are many different conventions for naming plural counters. How should containers be named? When I tweeted about this, Tavi Burns, I asked if I call person objects people, and he stopped me there. He said, no, you would never do that. Call it person list. Always use the singular, and because then you never have to match up the weird English plural with the singular form. And his advice actually matches very well with what my relational database friends do, because they are always giving tables singular names, not plural, because the sequel comes out better. And modern scientific Python code does the same thing. It will write something that looks very innocent that's actually operating on 200 X's and 200 Y's all at the same time. I would have been tempted a year ago to say, well, the Y array is 0.5 times the X array, to remember that these are each big lists of numbers. But the scientific people just write it like it's a single operation on floats, because they can just throw vectors in there and do 1,000 of that operation at once, using singular names for what are really huge arrays. So I often now will use the singular with some other information attached to tell me what kind of container it is. So that's the problem of pluralization. Two last tidbits. Ned Batchelder wrote a great blog post. The YAML library for Python has load, which will execute arbitrary code contained in the YAML it's given. And so they added safe load. And he argues that that's the stupidest thing ever, because the programmers who need safe load are the ones that will never find out about it. And so you should actually make the dangerous operation the one that is qualified. And then if I'm documenting what a hash table or dictionary does, I find I always get confused if I use plurals. The singular makes it clear that one thing maps to one other thing. I will report back to you as I continue to observe more habits because I think there's a lot more here. But that's all I have to say right now about naming in Python and in dynamic languages. Thank you very much.
Brandon, we would like to thank your presentation, and we have time for 2 questions, so if somebody's...
First of all, wow, that was a little loud, sorry. I'd like to mention that I share your ideas, but why is this really, why there is the reason that we have to talk about these things at the first place in a conference? If you think about it, it generally kind of tells a lot about how people are writing code. And if you do the naming right at the first place, you'll save yourself, well, a lot of your own hair years down the line, but also ensures, well, sorry, that was not targeted to you, sorry. But see, I made a point. Anyway, so, but also in collaboration, why is that we need to talk about these things? Because generally not everybody tends to follow these sort of principles. And within collaboration, I think it's much more important, and some people don't really understand the need of these sort of things. Is it because they are lacking the attention to detail, or because they are in a rush, or why is this? And how can I fight it in a way that I do not look like a control freak? No, honestly.
Was that 1 question or 3? Okay. I find that many things I do in programming never rise to the level of verbal formulation. That something will annoy me about some code, my code or someone else's, and I'll work on it and then I'll feel better. But if I am in a hurry, I don't step back and think, what did I just fix? Why did changing that name help me understand this function more? So I would see the function of a talk like this. When I give talks like this, I am trying to surface and make explicit things that we maybe do as sort of little OCD habits that we've never formulated, because once they've been described, when you go back to the office, someone might say, that's why I always feel like when I go read Todd's code, it's always a little different than everyone else's, and I don't know why. And I think that talks like this can just help us create a vocabulary for discussing how does our group do names? How can we make the impedance mismatch very small when I move between her code and her code on a single team? I don't know if I answered your question, but I think I answered some question.
Okay, and the last question is...
Hi. Hi, thank you for the talk. So I'm not sure if we can predict or be future-proof for the naming convention, because it often depends on the context. Like you often say you do have to create blah blah, but not in the math. But it's just like in the math context people happen to use, right? And your song URL, it's actually not really everything, because it had the URL of the domain. And in case of, for example, Amazon, you could have same song URL for Amazon UK and US. Then do I have to think, well, this is Amazon UK song URL? So like it all depends on context. So I'm rather for you just have to be prepared to change when your domain context change, rather than try to think you know the answer from the start.
And yes, so the very good point. While writing the first version of the code might point out naming inconsistencies that I can fix right then, it might be in a later version of the software that I realize that there's an additional ambiguity that needs to be removed. Do I go rewrite the whole thing right when I discover that? I try to treat these kinds of improvements like any other refactoring. Very often, with any kind of refactoring, sometimes I see code that needs refactoring, but there is something else I'm trying to get done, and I have no reason right now to modify that code. So often I have a little list of small improvements to make the next time I have an excuse to rewrite that function. Because if I'm going to be in the code anyway, and if version control is going to show that a function was rewritten, I can for free go ahead then and make the names more specific or do any kind of refactoring. So I try to use that same balance. If you refactor too thoroughly, all of your code is changing all of the time and you go too slowly. But if you never refactor, it can never become consistent. So I try to fix things when a bug or something else makes me go change that code anyway. If I don't have to touch the code, it can look kind of ugly. But the moment I have to touch it, I'm going to fix everything about it that I can find. Is that okay? Thank you very much.